Okay, welcome to the recording of the end of chapter 5 and our review of rational functions. It's just a quick basic review. So if you're just tuning in and you've printed out your review sheet, then go ahead and pause the video right now and go ahead and give the 3 problems a try. And then when you push play, you can watch how they're done. So pause now. All right, I am back, and we are going to do these 3 problems. The first one is just the graph of the basic reciprocal function. And so we're going to go ahead and graph that together. So here goes. If you are on the test and you blank about the reciprocal function, all you have to do is plug in some points. And so the basic points we used, starting with x equal to 2, when I'm at x equal to 2, the reciprocal of 2 is 1/2, so that will be the y value. When I'm at x equal to 1, the reciprocal of 1 is 1, so that'll be the y value. When I go to x is 1/2, the reciprocal of 1/2 is 2, and that will be the y value. At x equal to 0, 1 over 0 is undefined, so that reminds us that we have a vertical asymptote here at the value x equal to 0. Okay, that is my vertical asymptote, and a reminder that our rational functions will never go through a vertical asymptote. On the other side, when x is -1/2, the reciprocal of -1/2 is -2. At x equal to 1, the reciprocal of -1 is -1. And then finally at -2, the reciprocal of -2 is -1/2. One other thing that we noticed when we first introduced this was that because the numerator is 1, the y value will never become 0. And so that means that I have a horizontal asymptote. Horizontal asymptotes tell us what happens as the function gets further and further away from the origin. When you take pre-calculus, you'll call this a limit as you look at this. And so what's happening as I sketch the graph here is the graph's going to go through these points, and the asymptotes are going to determine the behavior of the graph, and then through these points. And that's what I am looking for when I grade your work on this, is for you to understand the behavior of the graph. Okay, most of our points are estimates, so just do your best to plot the points. Now, the next problem right next door is a transformation, just practicing and reviewing our transformations. Specifically, I have chosen 2 translations of our basic inverse, our basic reciprocal function. So once again, I'm just going to real quick, I'm going to, if you need to, you can always plot your basic graph. And so I'm doing that in pencil to keep that nice and light and as minimally distracting as possible. So here is my basic graph. And then the thing that I would ask myself first when I go to do this problem is, when I have the 1 over x minus 5, and then the plus 3 on the outside, what is happening to the basic graph? Well, the plus 3 is going to move the graph up 3 units. And then this minus 5 that's attached directly to the x, that's going to move the whole graph right 3 units. And so I'm going to go to my basic graph right here. And before I even worry about my points, I am going to do my asymptotes. And so since the graph moves up 3, that means that I'm going to go 1, 2, 3 units up, and I'm going to make my horizontal asymptote up 3 units. And then I'm going to do my vertical asymptote right. Oh, I'm sorry, I wrote right 3. That number is clearly 5. My apologies. So that I'm going to go right 5 units. And so here is my vertical asymptote right there. Now, you can do one of 2 things at this point. What I'm going to do is I'm going to take my original basic function, and I'm going to move the whole thing right 5 and then up 3. Another thing that you could do is you could treat the intersection of your asymptotes as another kind of pretend origin and just graph your points from that reference right there. But I'm going to go right 5 up 3. So this first point right here, 1, 2, 3, 4, 5, and then 1, 2, 3 up, I'll make my point. This one, 1, 2, 3, 4, 5 to the right, and 1, 2, 3 up. And finally, 1, 2, 3, 4, 5, and then 1, 2, 3 up. And so here is the right half of my graph. Okay, asymptotes determine the behavior of the graph. And then secondly, the other part is 1, 2, 3, 4, 5, and then 1, 2, 3 up. 1, 2, 3, 4, 5 right, and 1, 2, 3 up. And last but not least, 1, 2, 3, 4, 5, and then 1, 2, 3 up. And here we are, the asymptotes determining the behavior of the graph, and there is my transformation. I kind of missed the point there, but you get the gist. Last but not least, I have a rational function that is not in our standard form of a reciprocal function. And so what I'm going to do is I'm going to use these promptings to get information to draw just the most basic of sketches of this function. So the first thing that we're going to do with this is we're going to determine what the vertical asymptotes are. And so the question to ask yourself is, where do vertical asymptotes occur? And vertical asymptotes always occur when our denominator is equal to 0. We cannot divide by 0 in our real number system. So I'm going to say the vertical asymptote occurs when x minus 1 equals 0. And so that is the line x equal to 1. So I'm going to go to my graph and I'm going to draw a vertical asymptote here at the line x is equal to 1. As a sub-question of that, since we have the vertical asymptote and we know our graph will never go through this vertical line right here, that allows me to define the domain. So the domain starts off as negative infinity all the way to positive infinity. But now I have to notate that I'm skipping over this value 1 that we just found. And so the way we do that in interval notation is we say, okay, my domain is going from negative infinity to 1. And I use a parenthesis here because I am skipping the value. And then union, because all of this makes one domain. And then another parenthesis because I'm skipping the value 1 to infinity. So that value 1, you can see from the graph, it divides my x-axis, my domain, into 2 intervals, negative infinity all the way to 1, and then 1 to infinity. The next prompting is my horizontal asymptote. And as we saw when we went through this, there are 2 situations that I have that we will encounter with horizontal asymptotes. The first happens when the degree, meaning the highest power of the denominator, is more than the degree of the numerator. And in that case, the horizontal asymptote is always y equals 0. The situation we have is that the degree, meaning the highest power on the x of my numerator and denominator, is the same, at which point my horizontal asymptote is going to be the ratio of the coefficients in front of those terms. So 3 over 1, and that is the y value 3. So I will go ahead and I will make my horizontal asymptote. That's my reminder of what the graph, how the graph is going to behave. The rest of this is just getting some points to get some reference so I can draw my sketch. I want to know where my y values are in relationship to the asymptotes. I also want to know, does my graph happen to cross the horizontal asymptote? Because again, horizontal asymptotes deal with the behavior the further away from the origin you get. It is possible for graphs to cross the horizontal asymptote closer to the origin. So the first point that is relatively easy to get is my y-intercept. And you get the y-intercept by plugging in the value x equal to 0. Okay, that's going to give me where the graph crosses the y-axis. So when I do that in the numerator, I have 3 times 0 plus 1. In the denominator, I have 0 minus 1. And that is 1 divided by negative 1, or, oops, I'm off the screen a little bit, my apologies, negative 1. So at the x value 0, my y value is negative 1. So I will just make a nice blue dot right there. The next point of reference to get is my x-intercept. The x-intercept happens when the function value is 0. So for instance, when my 3x plus 1 over x minus 1 equals 0. The good news when dealing with a rational function is that it takes on the value 0 when the numerator is 0. 0 divided by whatever number. So I can just now limit this to 3x plus 1 equals 0. And just for room's sake, when I subtract 1 and divide by 3, I get the x value negative 1/3. So at the x value negative 1/3, the y value or the function value is 0. So that is right about here. Now, before I get excited and I connect those dots and use the asymptotes to determine the behavior of the graph, I do have to see, does this cross the horizontal asymptote? And the way that we figure that out, I'm just going to draw a little arrow so you see where I'm going to do the work. The way we figure that out is we take the function 3x plus 1 divided by x minus 1, and I determine, does it take on the value that I found in step 2 of the horizontal asymptote? Does it equal 3? All right, so this is just a rational equation that I'm being asked to solve here. And so I'm going to first multiply both sides by that denominator. So x minus 1, I'm going to multiply both sides. Here, the x minus 1's cancel, and I'm left with 3x plus 1. On the other side, when I distribute, I have 3x minus 3. And we know one of two things. If I end up with an x value here, that's where it does cross. That's the x value. It crosses the horizontal asymptote. But in this situation, when I go to solve, I notice that on both sides of this, the lights went out in the room, everybody. Sorry, hang on a second. Let me get the lights back on. All right. Oh, the trials and tribulations of making a video. Sorry. So when I subtract 3x from both sides, I notice all of my x's cancel, and I'm left with this contradiction statement. 1 equals negative 3. Well, we know that's clearly not true. And what that tells me is, does the graph cross the horizontal asymptote? The answer is no, it does not. It does not cross it. So now what that means is I can now go to my graph, and with confidence, I can say that this left-hand side is just going to look something like this. I'm going to use the asymptotes to determine the behavior of the graph as I draw my little sketch. You're always welcome to get more points, because more points means more confidence, but that is the sketch that I'm looking for. And the last thing I'm going to do is I am going to get a point over here to determine where are my y values. Are the y values above the horizontal asymptote, or the y value is going to be below? And so what I'm going to do is I'm going to take this x value right here, the x value 3, and I'm going to plug in x equal to 3. You're welcome, of course, to get more points. More points means more confidence. So when I plug in the x value 3 in the numerator, I have 3 times 3 plus 1. In the denominator, I have 3 minus 1. 3 times 3 is 9 plus 1, that equals 10. 3 minus 1 is 2, and that means that when I plug in x equal to 3, my y value is 5. So I'm going to plot that, and then I'm going to one more time use the fact that the asymptotes determine the behavior of the graph, and I'm just going to use that to set my boundaries, and here goes, and there is my graph of my rational function. We're just doing a sketch. That is what I am requiring. That's the minimum amount, because that tells me, do you understand the behavior of the rational function? Good luck. Email me if you need anything.